Test, test, test. Okay. In physics, motion is a change in position of an object object with respect to time, also on its reference point. Motion is basically typically described in terms of displacement, direction, velocity, acceleration, time, and speed. So what does that say? Well, let's look. Let's look at this. These are motion graphs basically. Well, motion graphs describe the movement of an object. Like I said, related to time. Time's in the bottom, but it's also related to displacement, velocity, acceleration. You have time, you have speed, and you have direction, positive, negative. Well, basically, what motion describes is like how the object moves. Well, you can see the blue is position, red is velocity, and green is acceleration. Well, in the displacement for time graph, the blue displacement one, the blue is related through all three graphs, red is related through all three, and green related through three. So if you have blue in displacement with a curve of x squared, basically, that's the graph, you get this. But now let's take the velocity of it. You get a graph that says y equals mx plus b. Then for this one, you get y y would always be the same, but x is always changing. So for the red graph, you get basically almost the same thing, but you have the x squared. You have y equals mx b, and you have y is the same, and x is always changing. And over here, it's 0 because that's the slope of this is 0. So let's go to the green line. It's all 0 because of that's another possible way. Displacement can be 0. So if displacement is 0 and time is 0, sorry, displacement is 0, velocity will be 0, and acceleration will be 0. And basically, that's how you describe it with the graphs. Now let's use a real life example. Well, you have a happy face. Let's say it can roll. It rolls, and it rolls. It rolls at a constant velocity, which means it also has a 0 acceleration. It rolls at a constant velocity, which means acceleration is not changing. So if displacement is going to look like this, because it's just rolling. So because x is being squared, x is getting greater and greater, while displacement is getting greater and greater. Well, velocity is a constant. This y equals mx plus b, so that's what the graph will look like right here. But acceleration would be the same always because constant acceleration velocity means acceleration is a constant number. Now let's say this happy face had the displacement of this line. Well, that means velocity is now like acceleration if position graph like this. So basically it's saying that, oh, y equals mxb and y equals mx plus b, that's what displacement is here. Velocity is basically y is the same while x is changing. Now the green, that just means the thing isn't moving. And that basically is how you describe motion. Now let's look at a common misconception. Well, a big misconception, well, not really big, I bet you, well, here's people get, well, here's something they get wrong all the time. Well, they don't know why they get this. Well, like, they think, oh, if this is like this, why would this be this? Well, this blue line, I'm talking about blue lines right now. This is this, why would this be this? Well, basically, you're just taking the slopes of them. And if you want to do that without physics, well, let's look at this is what you do. I need to pause this. I don't know how to pause right now for some reason. Now, here's a misconception I get. So people say, oh, here's a misconception. If acceleration is negative, that means velocity must be negative. That is not true. In the motion, let's throw the ball up. We throw the ball up, it goes whoop, shoo. So basically, what you just did was that you made displacement look like you would have this. Ignore this is h, this is actually x. So what is happening? Oh, so the ball displacement is going up and goes down. But what is right here? What is this equal to right here when you make a velocity graph? Well, since it's the point where it goes to positive slope to a negative slope, that has to equal 0. Because that's when the ball stops moving for an instantaneous point. So let's look. So let's go to the velocity graph now. See velocity, negative slope, but positive. Negative slope, not negative. Well, that doesn't mean acceleration must be positive. Actually, this means this graph shows that acceleration is negative for the whole thing. Well, why? Because like we learned in a different screencast, screencast that he did, there's a force on Earth always pushing down. That's called G, gravity. And that's always pushing down at 9.8 meters per second squared. And since down is negative, there's always going to be negative acceleration if you throw a ball like that. And that is a common misconception that most people get wrong. And this is how you can, and that's how you fix it. And that is how you really describe motion.